Swayam Prabha. Digital India. Educated India.
Now, I will take an example circuit and calculate its Z parameters. I will take the same circuit that I took for the Y parameter example, so that you can relate different parameter sets for the same circuit. Okay. So, this is the circuit I took, and I have two cases for measurement. One in which port 2 is left open circuited and a current source is connected to port 1, and in the other case where port 1 is left open circuited and a current source is connected to port 2. Okay. So, extremely simple circuit, very easy to analyze. So, I1 flows through these two resistors. Okay. So, the voltage here across port 1 is the series combination of these two resistors 2 kilo ohms times I1, whereas the voltage across port 2 is I1 times this resistor 1 kilo ohm. Okay. And in this circuit, no current flows through this 1 kilo ohm because it is in series with an open circuit. Okay. So, the voltage drop across this is also 0. All of this I2 flows into 1 kilo ohm, giving you a port 2 voltage of 1 kilo ohm times I2, and the same voltage appears here, and that is 1 kilo ohm times I2. Okay. So, from the first circuit in which we have port 2 open circuited, we will get Z11, which is V1 by I1 with port 2 open circuited, I2 equal to 0 to be 2 kilo ohms, and we also get Z21, which is V2 by I1 with port 2 open circuited to be equal to 1 kilo ohm. Okay. So, Z11 is nothing but the resistance looking into port 1 with port 2 open circuited, and if you look into port 1, you will see the combination of these two resistors in series, which gives you a 2 kilo ohm resistance. Okay. Now, let us go to the other circuit, and from this we will get Z12, which is V1 by I2 with port 1 open circuited, which gives you 1 kilo ohm, and Z22, which is V2 by I2 with port 1 open circuited, which is also 1 kilo ohm. Okay. So, these are the 4 Z parameters, and Z22 here is nothing but the resistance looking into port 2 with port 1 open circuited. If you look into port 2, you will see this 1 kilo ohm, and this 1 kilo ohm which is hanging. So, it does not contribute anything. So, the looking in resistance into port 2 is just 1 kilo ohm, and that is what we see. So, the Z parameter set of this particular circuit is 2 kilo ohm, 1 kilo ohm, 1 kilo ohm and 1 kilo ohm. Okay. And you can verify for yourselves that this Z matrix is the inverse of the Y matrix, which you derived for the same circuit in the earlier example. Okay. Now, let us make the circuit slightly more complicated by adding a control source. Again, I will take the exact same example I took earlier, so that you can relate different parameter sets for the same circuit. Port 1, port 2, 1 kilo ohm, 1 kilo ohm and 2 millisiemens. Okay. So, I will go through this analysis quickly, because circuit analysis by now is familiar to you. Okay. So, you can work this out yourselves and compare your answers to what I derive. So, again I need two cases, one in which port 2 is open circuited, a current is applied to port 1, and another case where port 1 is open circuited and a current is applied to port 2. Okay. So, now we have a slightly more complicated situation with the control source. Now, if you observe this circuit, I 1 flows through this 1 kilo ohm and then the parallel combination of these two. So, the voltage drop across this is 1 kilo ohm times I 1. The current through this resistor is I 1 minus whatever current is flowing through the current source, which is I 1 minus 2 millisiemens times V x, and in this circuit you see that V x equals V 1, okay, because the voltage here is V 1. So, V x is the same as V 1. So, I will write this as I 1 minus 2 millisiemens times V 1. So, that is the current flows over there. So, the voltage drop across this is this current times 1 kilo ohm, which is I 1 times 1 kilo ohm minus 2 millisiemens times 1 kilo ohms times V 1, which is minus 2 V 1. Okay. And also the voltage V 2 is nothing but the voltage drop across this 1 kilo ohm resistor. Okay. So, I will write these two equations. First of all, V 1 equals the sum of voltage drops across this one and that one, which is 1 kilo ohms times I 1 plus 1 kilo ohms times I 1 minus 2 V 1. From this we see that V 1 is 2/3 kilo ohms times I 1, and we know that V 2 is the voltage drop across this. So, V 2 is 1 kilo ohm times I 1 minus 2 V 1, and V 1 we have already calculated. So, it is 2 times 2/3 kilo ohms times I 1, which is basically minus 1/3 kilo ohm times I 1. Okay. And with port 2 open circuited, we know that V 1 is nothing but Z 11 I 1 and V 2 is nothing but Z 21 I 1. Okay. So, Z 11 is this quantity and Z 21 is that quantity. Okay. So, you need a little more calculation, and I went through it quickly, but the analysis of the circuit with the current source I 1 applied is routine by now. So, you should be able to do this yourselves. Okay. And I will do it for the other case as well. Let me copy over this part of the circuit. Port 1 is open circuited. Okay. Now, again the current through this 1 kilo ohm resistor is 0 and V 2 equals V 1. Okay. In this particular circuit, this is not true in general, of course, and also V x happens to be equal to V 1. So, now the current through this 1 kilo ohm resistor, by the way, through this it is 0, and through this vertical 1 kilo ohm resistor is I 2 minus whatever current is flowing through the control source, which is I 2 minus 2 millisiemens times V x, which is the same as V 1, which is also the same as V 2. Okay. So, I am going to write that right away. So, now this voltage drop V 2 is the current through this 1 kilo ohm resistor times the 1 kilo ohm resistance. Okay. So, V 2 we get it to be I 2 minus 2 millisiemens times V 2 times 1 kilo ohms, and from this we get V 2 to be 1/3 of a kilo ohm times I 2, and we also said V 1 is the same as V 2, which is also 1/3 kilo ohm times I 2. And we know that with port 1 open circuited, V 2 is nothing but Z 2 to I 2 and V 1 is nothing but Z 1 to I 2. Okay. So, this is Z 1 2 and that is Z 2 2. Okay. The Z parameter matrix for this circuit turns out to be 2/3 kilo ohms minus 1/3 kilo ohms, 1/3 kilo ohm and 1/3 kilo ohm. Again, you can go back to the old Y parameter example, and this is the inverse of the Y matrix for this circuit. Okay.